be doing the 2011 AP Calculus AB free response questions. Alright, for question 1, it says, for 0 to 6, a particle is moving along the x-axis. The particle's position, x of t, is not explicitly given. The velocity of the particle is given by v of t, which is like this function right here. And then the acceleration of the particle is given by this function right here, 8 of t. And then it says x of 0 equals 2. Since this is a graphing calculator question problem, we're going to go ahead and plug in v of t, this function, and find the value where it's 5.5. So I already plugged in the function, and now we're going to go ahead and graph it, and we're going to find the point where it's 5.5. Now I'm going to press second trace, and we're going to find the value of 5.5. When answering this question, it would be easiest to round to the third decimal, so the answer would be negative 0.453. And now we're going to do the same thing, but this time it's going to be with the acceleration function. So I have it right here, and now we're going to graph it. Now once we graph it, we're going to do second trace value, and the value is going to be the same again, which is 5.5. When rounding to the third decimal place, the value is going to equal negative 1.359. According to this function analysis sheet, since our first answer was negative 0.453, it is less than 0, and right here since it says the velocity function is less than 0, the particle is moving left down, so it is negative. And for the acceleration one, since it is negative, it is less than 0, so it has negative acceleration, so it is also going down. Part B asks, find the average velocity of the particle for the time period from 0 to 6. If we look at our hot stuff calculus sheet, it says to find the average velocity, we would use either of these formulas, so I'm going to go ahead and use the second one. Now we're going to go ahead and plug in 0 to 6 into our formula. So 0 would be A, and then 6 would be B, and we're going to use the BT function, and we would just plug that into our calculator. When plugging it in online, the answer turned out to be 1.949. To find the total distance traveled between 0 to 6, so we would go ahead and look at our calculus sheet again, and we would find the integral from 0 to 6 and then plug in VT, but for the absolute value. When plugging it in, the answer turned out to be 12.573. Part D asks, for 0 to 6, the particle changes direction exactly once. Find the position of the particle at that time. So what we're going to do here is we're going to go ahead and plug in VT, and then from 0 to 6, we're going to see where it exactly changes position. So we're going to be finding the zeros. Once graphing the function online, you can see that from 0 to 6, it's above the x-axis, but then once it hits at this point right here, it goes below the x-axis, so that's going to be our 0, which is 5.196, which rounds up to 5.2. I changed the integrals from 0 to 5.2 because up until 5.2, it's been going the same direction, so that's why I changed the integrals. And then I plug in v of t, which is our function. That's one part of the equation. And then after this, since up here it says from the beginning, it equals 2, so I'm going to go ahead and add 2. So when I plugged all of this into the calculator, my answer turned out to be 14.1347. And that's how you do part A, B, C, and D of question 1 of the 2011 AP Calculus AB free response questions. Alright, so question 2 asks, as a pot of tea cools, the temperature of a tea is modeled by a differentiable function h for 0 to 10, where time t is measured in minutes and temperature h of t is measured in degrees Celsius. Values of h of t at selected values of time t are shown in the table above, which is right here. And then for part 8, it says use the data in the table to approximate the rate at which the temperature of the tea is changing at a time t equals 3.5. And then we have to show our work in this problem. Okay, the reason why I did this was because it says t equals 3.5. So then 3.5 is between 2 and 5. So then I just used the slope formula because it's asking rate of change. And so I subtracted 52 minus 60 because that's y2, and then this is y1. And then 5 minus 2, which is x2 minus x1, and then the answer turned out to be negative 8/3. Part B asks, using the correct units, explaining the meaning of this integral right here in the context of this problem. Uses trapezoidal sum with the 4 sub-intervals indicated by the table to estimate the integral. Since this formula right here is the average value of function just like the previous problem, we're going to go ahead and explain why it's using the 4 trapezoidal sums. Alright, so when multiplying and adding all of this together, the answer turned out to be 529.5. And then since we are finding 1/10 of it, we just multiply that answer with 1/10, and then the answer turned out to be 52.95 degrees Celsius. Part C asks us to find h prime of t, so it's the derivative of this function over here because this is h of t, which is the antiderivative of this. So now I'm going to find h of 0 and then h of 10 using this table over here, and then I'm just going to subtract them. Since in this problem the rate of change is the total change in temperature, that's why we subtracted h of 10, which was 43, and then h of 0, which was 66. And in total, it turned out to be negative 23 degrees Celsius between the intervals 0 through 10. Part D of this question says at t equals 10, biscuits with temperature 100 degrees Celsius were removed from an oven. The temperature of the biscuits at time t is modeled by a differentiable function b, for which it is known that b prime of t, which is this. Using the given models at t equals 10, how much cooler are the biscuits than the tea? Okay, so the reason why I added 100 because that was the starting point of the biscuits from the beginning, and then I added this because this is the rate of change. And so when I plug this into the calculator, once plugging this into the calculator, the answer turns out to be 34.1827. The reason why I subtracted 43 minus 34.183, which was the answer I got when I plugged all of this into the calculator, was because it's asking for t equals 10. And t equals 10 up here in the table equals 43, so that's why I subtracted them, and in total that's what I got. And that's the final answer of how much cooler the biscuits are. And that's how you do number 2 on the 2011 AP Calculus AB for response questions. Question 3 says, let R be the region in the first quadrant enclosed by the graphs of f of x and g of x, as shown in the figure above. And then part A says, write an equation for the line tangent to the graph of f at x equals 1/2. For this question, it's always good to know which one is which, between which one is f of x and then which one is g of x. And this one, the bottom one, is going to be f of x, and then the top one is going to be g of x, because knowing from previous math classes, sine is always the one that's always like squiggly, you know, so it's always on top. And then f of x, it's usually x to the third power, which usually goes like this. So then that's how I know which one is which. The reason why I wrote this equation because going back to our sheet, it says to write an equation of a tangent line. I used y minus y1 equals m, which is a slope, times x minus x1. So that's why I wrote the equation right here. Alright, so trying to find the equation of a tangent line, I use the coordinates 1/2 and then 1, which is x1 and then y1, and I just plugged it in, which is, 1 and then 1/2. And then I still need to find the slope, so I just found the derivative of f of x, which was 24x to second power, and then I just plugged in 1/2 because that's what it's asking us, is x equals 1/2. So I just plugged that in, and then the answer turned out to be 6. So that is my slope, so I just plugged it into the whole equation, and that will be my final answer for A. For part B, it asks to find the area of R, which is this right here. Back to my calculus notebook that I used all year. It says finding an area between two curves, I have to subtract between A and B, which in this case is 0 and 1/2, because that's where the area of R stops. And then I'm gonna have to subtract f of x, which is this one right here, and then minus g of x, which is the top one. So now that I've integrated sine pi of x and then 8x to the third, I'm going to go ahead and plug in 0 for both of them, and then 1/2 for both of them too. Okay, so when I plugged in 0 and then 1/2, 1/2, it turns out to be this. So then cosine of pi over 2 equals 0, so it would be 0 times negative 1 over pi, and then so that would just be 0, so then it would be negative 1 over 8 plus 1 over pi. Moving on to the last part of this question, it says, write but do not evaluate an integral expression for the volume of the solid generated when R, which is this over here, is rotated about the horizontal line of y equals 1. Going back to my calculus notebook, it says formula of volume with the hole. So this is the formula we're going to go ahead and use, because when we're rotating it, it creates a hole. My smaller is g of x because it is closer to y equals 1 over here, distance wise, and then my big R is f of x because it is further away. And now I'm just going to go ahead and plug it into the whole formula. This would be my final answer for part C of question 3, and this concludes question 3 of the 2011 AP Calculus AB free response questions. Question 4 says, the continuous function f, which is this right here, is defined on the interval -4 to 3. The graph of f consists of 2 quarter circles and 1 line segment, as shown in the figure above. Let g of x equal this. And then on part A it says, find g at -3 and then find g prime of x and evaluate g prime at -3. The reason why I did this is because I'm trying to find the area of the quarter circle. So then area of a circle is pi r squared, and so I put it over 4 because it's a quarter of a circle. The reason why I put minus 9 pi over 4, even though my answer when I plugged in 3 is positive 9 pi over 4, is because the integrals say from 0 to -3. So from 0 to -3 would go backwards, so that's why it's negative. So now that I found g at -3, that's the first part of what A is asking for. So now I'm going to find g prime of x, which is this over here. So then I derived 2x and then I got 2, and then since this is an integral, deriving it would be the antiderivative, so it's just f of x. Since I already found g of x, I just plug in -3 because that's what it asked for. So then I just plug in -3 into x, and then f at -3, if we look at the graph over here, it equals to 0 because, you know, it equals to 0. And then I add 0 plus 2, and then that equals 2, and then that completes my work for part A. Part B says, determine the x-coordinate of the point at which g has an absolute maximum on the interval -4 to 3. And then it says, justify your answer. Going back to our calculus sheet, it says to find the absolute global maximum or minimum values, which is over here where it's asking us to find the absolute maximum. I derived and then make it equal to 0, and then that's how I found -2. My slope is -2 because in order for f of x to equal -2, which is this over here, I would have to go from the starting point down 6, and then over 3, so it would be 6 over 3. So 6 over 3, you divide it, and then you get 2. Having all this figured out with the y-intercept equaling 3, you just pretty much solve for x, and that's what I did, and my final answer turned out to be 5 over 2. So now that I found what x equals 5 over 2, I did the integrals from negative 4 to 5 over 2, and then from 5 over 2 to 3. So everything from negative 4 to 5 over 2 is above the x-axis, so it would mean that g prime of x is greater than 0. Since f of x plus 2 is still under the x-axis, that's why I put g of x is less than 0. Since our derivative is going from positive to negative, that's why I said that g has an absolute maximum at x equals 5 over 2. Part C asks for find all of x on the interval negative 4 to 3 for which the graph of g has a point of inflection, and then give your reason. So according to our sheet, in order to find inflection points, we're going to have to do like s numbers 1 through 3. So this is s, so we're going to have to find the second derivative and then make equal to 0, and then we're going to have to make a sign chart, and then we're going to have to find when it changes from positive to negative or from negative to positive. When x equals 0, it actually means that it is a critical number for the second derivative of g of x. My reasoning here that an inflection point of g is at x equals 0 because based upon the graph, the second derivative of g is actually the first derivative of f. So I'm just looking at when it changes from positive to negative or negative to positive. So right here, since it's above the x-axis, it goes it's like all positive, and then when it hits 0, it goes straight down, so it changes the way it's going. So that's why my reasoning of an inflection point is at x equals 0. Part D says, find the average rate of change of f on the interval from negative 4 to 3, and then it says there is no point C from that interval for which f prime of C is equal to that average rate of change, and then explain your reasoning why this statement does not contradict to the mean value theorem. Finding the average rate of change, it's basically what I did before on another previous problem. So then I just subtracted f of 3, which is negative 3, and then f at negative 4, which is negative 1, and then I just did them together over 7, which is just all of this, and then it equals to negative 2 over 7. In my calculus notebook, it says the mean value theorem. These are the conditions with f of x is continuous and differentiable within an interval or anywhere else. And then the second condition is f of a does not equal f of b. The third condition is that when you subtract f of b minus f of a over b minus a, it equals fc and equals the derivative of fc. In this case, the mean value theorem does not apply here because when x equals 0, it is not differentiable, so that's why it does not apply. And that concludes question 4 of the 2011 AP Calculus AB free response questions. Question 5 says, at the beginning of 2010, a landfill contained 1,400 tons of solid waste. The increasing function W models the total amount of solid waste stored at the landfill. Planners estimate that W will satisfy the differentiable equation of dW over dt equals 1 over 25 times W minus 300 for the next 20 years. W is measured in tons and T is measured in years from the start of 2010. Part A says, use a line tangent to the graph of W at T equals 0 to approximate the amount of solid waste that the landfill contains at the end of the first 3 months of 2010, and then T equals 1 over 4. I plugged in 1,400 because that's what it was at the beginning, so we're trying to find the slope here. So when I calculated all of this, it equals to 44. So this is basically the slope formula. So once I find 44, that's my slope, so I would just plug this in so it would be 44t plus 1400. And then for t, since it gives you 1/4, I just plugged in 1/4 for t. And then when I calculated all of this, since this is not a calculator question, I actually did the work, and then it equals 1411. Part B says, find the second derivative of dw over dt in terms of w. Use the second derivative to determine whether your answer is part of A in an underestimate or overestimate the amount of solid waste that the landfill contains at t equals 1/4. For part B, I'm going to find the derivative of dw over dt, which is this equation right here. So then I just multiplied it to make it easier. So then once I find dw over dt, like multiplied it all together, then I have to find the derivative, which is 1/25 dw over dt. And then after, I would have to plug in the original one, which is 1/25 times w minus 300. And then I would have to multiply it all together. 1,411 tons is an underestimate because since the beginning it said that it was 1,400 tons, so I'm going to plug in 1,400 into w. So if I calculate all this, it's going to be positive times positive, so that's why it is concave up. So my reasoning is, since the function is concave up, knowing that the second derivative of dw over dt is greater than 0 on the interval 0 to 1/4, 1,411 tons is an underestimate. C says, find the particular solution w equals wt to the differential equation dw over dt equals 1/25 times w minus 300 with initial condition w at 0 equals 1,400. I separated the w's on one side and then the t on the other from this equation right here, the one that we did before, to make it a little easier, and then I integrated it so that the integration of 1/w minus 300 equals ln of ln times w minus 300, and then I integrated this too. And now we're going to go ahead and solve it. When I plugged in 1,400 for w and then t equals 0, I calculated everything and the answer turned out to be 1,100 e to the power of 1/25t plus 300. And that concludes question 5 of the 2011 AP Calculus AB free response questions. For part 6, for question 6, we are giving a piecewise function. So then this, part A says, show that f is continuous at x equals 0. So we plug this in, f of 0, we use one of the piecewise functions that is given to us. So then we do 1 minus 2 sine of 0, equals to 0, so 0 times 2, and then it will be 1 minus 0, so that's why it's just 1. Now we're going to do when the limit approaches 0 from the left, and then when it approaches from the right. When solving, since they are both 1 and 1, and then so it meets at point 1, so it is continuous. That's why my reasoning was f is continuous at x equals 0 because f of 0 exists, and the limit of f of x coming from positive, which is right here, equals 1, and then coming from negative, which is over here, equals 1, exists. Now for part B, it says, for x to not equal to 0, express f prime as a piecewise defined function. Find the value of x for which the derivative of x equals -3. Now that I found the derivative of each piecewise function, we're going to go ahead and equal each of them to 3 and then solve for x. And this concludes part B. Now moving on to part C, it says, find the average value of f on the interval -1, 1. Going back to our calculus sheet again, it says to find the average value, we're going to go ahead and use this 1 over b minus a, and then for the integral of a to b fx dx. Once I integrated both of these up here, it turns out to be this. So now we're going to go ahead and plug these in. And now I'm going to go ahead and solve it. I made the problem a little simpler for me, so then I'm going to go ahead and solve for everything, because I combined everything. So like 0 plus 2, all that together. And that concludes the last and final question of the 2011 AP Calculus AB Free Response questions.